Welcome to the Python tutorial introduction. Overview. I start this presentation with a general overview of the Python language, its design principles, history, and list of notable advantages and drawbacks. In the next part, I focus on this tutorial's features, explain its level scale, its components and navigation, and finish with the tools you will need to write and run Python programs. So let's get started. Python is a general-purpose, high-level programming language that you can use to write all kinds of applications. It abstracts more system specifics. This way you can focus on your program's internals instead of low-level system details. It also allows you to write highly portable apps that run on multiple operating systems and hardware configurations. Python is mostly object-oriented, but borrows from other paradigms to provide you the freedom to choose how to approach the development challenges you will face. With its dynamic type system and flexible containers, you will be able to quickly design versatile data structures and create them on the fly. And the Python interpreter takes care of garbage collection, freeing memory as needed, so you don't have to worry about it. The Python developers designed the language with 5 major design principles in mind. First, beautiful is better than ugly. Second, explicit is better than implicit. Third, simple is better than complex. Fourth, complex is better than complicated. And fifth, readability counts. A bit of history. The Dutch computer programmer Guido van Rossum started Python in 1989 and still leads its development. Version 2 was released in the year 2000. It featured initial Unicode support and full garbage collection. It also made important changes in the development process, focusing on community involvement and transparency. Version 3 was released in the year 2008. It was a major cleanup effort with the aim of fixing some major design flaws. To achieve this, the Python developers had to introduce a set of backwards incompatible changes that made porting old code difficult. Compared with other programming languages, Python has some strengths and some weaknesses. On the plus side, it's a cross-platform and open-source project. You can easily write applications that run on Linux, OS X, and Windows. The syntax is intuitive and easy to learn. Only few braces and parentheses are needed, and nesting is done with indentation. Programs tend to be short and expressive. This results in a very fluid workflow. Strings consist of Unicode code points, which makes it easy to handle a wide variety of characters. During its history, the Python language has seen extensive cleanups, resulting in a consistent design and library naming. It's really good at math. You rarely have to worry about type limits. As an example, integer numbers can be so large that you have to scroll to fully display them, even with a tiny font. Calculations like 2 to the power of 1,000,000 poses no problem for Python. And the standard library covers a large array of tools. It's often enough to solve problems without having to rely on external libraries. And when that's not enough, you'll find plenty of bindings for the most common systems, applications, and services. On the negative side, because Python is a dynamically typed language, it has a mediocre runtime performance and is ill-suited for applications that need to optimally utilize the available computing resources. Usually, though, the development time saved by using Python is more important, especially for applications that spend most of their time waiting for user input or other events. Because it uses a global locking mechanism, it's also bad at concurrency. It's quite difficult to distribute work to multiple threads and processes. So far I introduced the Python language. With the next 2 slides I give you some introduction to this tutorial series so you know what to expect. To begin, there are 3 tutorial difficulty levels: Basic, Intermediate and Advanced. The units are released one at a time until the series is completed, so I suggest that you subscribe to my channel to get notifications of new tutorial unit releases. If you are new to Python or programming in general, you should start with the basic level, in which I explain the syntax, the data types, the inbuilt functions, the most used parts of the standard library, and general tool usage. This will give you a good foundation to create apps with Python. If you already have a good understanding of the Python basics, you should look into the intermediate units, which cover more applied topics and dive deeper into the standard library. And finally, if you're sophisticated in programming with Python, you will want to explore the advanced units. Unlike the other levels, these units focus on creating practical applications and are a good opportunity to sharpen your skills and discover new programming tricks. Units are hosted on tutorialcoding.com. With each unit, I introduce a new subject and demonstrate it with an example application. Along this example comes a description page and an embedded video in which I explain the subject matter. The tutorial comes with an index that links to the individual units and features a short summary of their content. This introduction is coming to its end. In this slide, I list the tools you will need to create and run Python applications. First comes the Python package containing the Python interpreter that is used to run Python programs, the standard library, and a collection of utilities and documentation. You can easily download the installer from python.org. If you are using a Linux distribution, you will likely have Python installed already. Some distributions have both version 2 and 3 packages installed. In this case, please make sure to use the Python executable with the suffix 3. You will also need a text editor or IDE to write Python applications. I suggest you choose one that understands the Python syntax, provides source code highlighting, and maybe auto-completion. You have a lot of choices here. If you already have a text editor that you are familiar with, you will likely want to stick with it. If you are unsure, give PyCharm a try, which is a well-rounded editor just for Python. I use the editors called Vim and Kate in this tutorial series. You will also need a shell to execute Python applications. In the examples, I use the common Linux shell called Bash. If you are not familiar with it yet, I suggest you give it a try. Of course, you are free to use other shells too. This concludes this presentation. I hope I could give you a comprehensive introduction to the Python language, made you eager to explore it, and see you again in the tutorial unit videos. Thanks for watching. As always, you can find the unit sources and notes on the tutorialcoding.com website that you can reach by clicking on the box with the orange annotation. If you found this video insightful and enjoyable, please like it and leave a comment. Subscribe to my YouTube channel or follow my Google+ or Twitter feed. Goodbye.